Welcome to Chat NDT with ASNT, a podcast from the American Society for Non-Destructive Testing. I'm Haley Cowens. To close out the year, we wanted to compile some moments from the many interesting conversations we've had in 2023. We also want to give you, the listener, the opportunity to help shape the podcast in 2024. Please consider spending a few minutes filling out our listener survey at surveymonkey.com/r/ASNT podcast, all lowercase, all one word. The link is also in the podcast description. This survey will give you the opportunity to tell us a little more about your podcast listening habits and the topics that you find interesting. It's a very brief survey, 6 multiple choice questions, but it will really help us out a lot. Thank you so much. Now for our year in review. You can listen to all the full episodes featured here, as well as all of our past episodes, in your favorite podcast platform or at asnt.org/podcast. In March, ASNT's Director of Publications, Jill Ross, sat down with NDT legend Chuck Hellier. Here's Chuck reflecting on his NDT career.
NDT has so many fantastic opportunities. And I can tell you that when I first started out, I had no idea what the world would offer to me. Just getting involved with NDT and being passionate about it. I think that makes a big difference. There are people today that will take a job and it's a job. But there's a lot of people in NDT who are really passionate. They've made it their life, their life objectives. And it has afforded me so many tremendous opportunities. I think the biggest opportunity that I saw was in the training, teaching people how to do the different methods right and being ethical about what their job is. At this time in our history, there's a lot of the ethics are sometimes missing. But I think with T, we want to do it right. It's got to be right. And I think there's tremendous opportunities. In my lifetime of NDT, it's given me travel. I can't even begin. I've lost track of the time. I used to keep track of the countries I went to, and I stopped when I got to 25.
Wow.
Been to most of the United States. And when I was president, I went and visited and talked at 32 of the ASNT sections. And it just gave me a tremendous opportunity to meet members and people interested in NDT. I've ended up with some tremendous, and I'm saying this because I think these opportunities are out there for anybody that wants to go after them. I ended up with some tremendous consulting projects that took me around the world. I now have participated in over 25 legal actions as an expert witness. I've done some pretty heavy consulting for the U.S. government. And some of the projects, oh my gosh, I think I could write another book.
In January, ASNT's Marketing and Communications Manager, Debbie Seagor, spoke with Alan Calder, Vice President of Sales for Advanced OEM Solutions and the Phased Array Company. Here's Debbie.
Why is phased array so important now?
So I'd say there was a kind of a step change in industry from conventional UT, which is basically a single element probe. I mean, there's probes that are what they call dual elements, but let's just say a single probe that's pulsing and receiving, and you're getting a single A scan or a waveform for each probe. And, I think some of it is generational because personally for me, like I say, I started really doing my hands-on UT in 2010, and we were lucky enough to have a phased array instrument. So I spent very little time doing conventional ultrasound and pretty much learned on phased array. So phased array brings some benefits over conventional. We can start with the pure, let's say, physics aspect of it, where, a conventional probe it's broken down by formulas and mathematics, but a conventional probe has a specific area of focus, and it's fixed. It's a function of the frequency of the probe and the diameter of the piezo element in it, but it's a fixed focus. So with phased array, or PAUT phased array, the phased means you're phasing the arrays, which basically means you have multiple, much smaller, multiple elements inside one probe. So what you do is phasing, or you applying time delays to these different elements within the array, which allows you to focus at different areas. So that brings a big benefit, where instead of having a static focus, I have a lot of flexibility on being able to focus my probe. So that in itself brings a big benefit. There's, let's say, a mechanical aspect to it, where, let's say, something like corrosion mapping, where with a single element probe, I'm, rastering. You've got the system, and it's moving the single element probe back and forth and back and forth. So with phased array, it allows you to do something they call electronic scanning. So there's some amount of that mechanical movement of the probe is replaced by electronic rastering or scanning of the phased array probe itself, because typically, let's say you have a 64 element probe, you're only actually transmitting, let's say in a corrosion application, with 8 of those elements at one time, let's say. And so and that 8, depending on the dimensions, let's say that 8 elements of that probe equals a quarter inch. Quarter inch is a common size of a probe, of a conventional probe. So instead of moving that quarter inch conventional probe mechanically, I can take that 8 element aperture, which equates to, let's say, a quarter inch probe, and electronically move it all the way to the other, through all 64 elements. So I scan with elements 1 through 8, and then I scan with elements 2 through 9, 3 through 10, all the way to the end of the probe. And then, so what that does is it allows me to minimize some of that mechanical movement. So my aggregate scanning time of a certain area is going to be less. And then also, you're going to get better resolution, because let's use a round number. Let's say there's a 1 millimeter pitch or spacing between each element. So I'm basically able to get a snapshot or a scan at every millimeter. When I have elements 1 through 8, and I move to scanning on elements 2 through 9, there's only a millimeter kind of difference. And so my coverage is much better, and I'm going to have much better resolution and viewing of the defect. And then one of the aspects I saw, and this was especially true in my work at Flawtech, and I think it's true across the board. In my work at Flawtech, I would, I was the feedback loop to our welders if they had done a good job. And so, it was kind of, I mean, I got along. That's one thing I miss about my old job, is I missed all the welders. They're all good guys. I really enjoyed working with them. But it was kind of an immediate feedback loop for them, where they'd weld a sample up, and then I'd scan it and tell them, hey, this is good or this is bad, or maybe you have a lack of fusion, some unintended lack of fusion in here somewhere. So if I'm doing that with conventional, I've got this, you know, let's say, skeptical welder, and I've got to convince him that, hey, you made a mistake.
I mean, they haven't embraced you. They don't want to hear what you have to say.
Well, so with conventional, you're basically showing them a squiggly line and telling them,
Mhm.
hey, you messed up. Here's this little spot on this squiggly line. Where with phased array, if we look at something like a weld scan, I'm able to place an overlay of the weld profile on the screen. And let's say you have a sector which shows a much larger, it's usually kind of a triangle shape, but so I'm able to overlay my phased array data on top of the weld, and it's all nice and colored. Red's bad.
Right.
So I'm able, instead of saying, hey, this squiggly line that you're seeing shows there's a lack of fusion, if I'm right and it's a lack of fusion, I'll be able to overlay it on the profile of the weld, and it'll have a nice big red blob on the side of the weld bevel. And it's, oh yeah, okay. So how does that work on larger? If we think about, I mean, that's one aspect of it. If you talk about in an organization, communicating things to a manager or a customer of how to show that your phased array technique is good, it's much easier for the layperson to see phased array data. And I wouldn't say it's fully intuitive, but it's much more intuitive than just a standard conventional A-scan.
In July, we hosted a conversation between two technicians, Brent Moulton and Stetson Watkins. Here's Brent talking about volunteering with ASNT.
So I go a lot with like Debbie or some of the other staff, and we go to these STEM conventions. And it is so fun to speak with like different like science teachers or professors from different colleges and
Sure.
explain to them what NDT is. And like, hey, you might have a couple students that would be interested in this. And then kind
That
of
is awesome.
yeah, it's just so fun. And like I always say the story I tell is I was down in Houston last year, and I was, the common buzzwords like, ionizing radiation, capillary action, and it was so funny because I had these professors looking at me and they're like, what do you do again? Like they were blown away that I was able to, I mean, I'm sure on a much basic level compared to what they really teach and what they are proficient in. But the thing is we just need to know how it works,
Definitely.
so that way we can detect our defects or whatever.
For sure.
And yeah, it was pretty fun talking with the different teachers and stuff, and just kind of
Right.
sharing a great career.
For sure, man. I feel like there's so like so many career fields, right? Where you have this school curriculum, like these things that you go and learn. And then when it comes to doing your job, you literally leave all that in the dust. And we can't do that. You know what I mean? Like you really have to understand like if we're talking about ultrasonic testing, you have to understand the effects of increasing or decreasing the frequency. Like when would you go from a 15 meg to a 1 meg or whatever, right? Like those things, you have to understand those relationships. What are the impacts of changing those things? And so yeah, that's what I love so much, is that it's truly a field where you can go and apply physics that are fun to learn, but then you get to go and use them and apply them to making the world a safer place, right?
Yeah, and that's one thing, I'm always honest about it. Back in high school, I had a really hard time sitting through class. Like, I'm a very energetic person.
Me too,
So,
man.
sitting in a classroom for an hour or however long the class was, I mean, it was like nearly like physically painful for me. But I always like loved physics and science, where I would spend a lot of my time just kind of like researching and learning about this on my own. And then
For
once I
sure.
started learning about NDT, I'm like, oh, yeah, that's the wave, that's frequency, or that's the electromagnetic spectrum. Like,
Right.
how cool is that? Like, I love that frequency and like light waves and all that stuff. Like, it's so interesting to me, where I don't even think about being stuck in a classroom learning this, because it's so interesting.
For sure, man. Brent, I was the same way, man. I was a terrible high school student. I barely made it out. And honestly, like I mentioned earlier, that when I learned about NDT, I was working at a factory like there in Tulsa, just because when I got out of high school, I was like, there is no way I'm going to go sign up for a 4-year college program or whatever, like I'm going to go to school and go do something, just I was like, there's no way I'm going to do that. And part of that is because of the confidence or the lack thereof the lack of confidence that I had really from high school, right? I mean, I didn't get it. It didn't stick. I didn't like math. I didn't like any of it. And then after working in the NDT industry for a couple years, and after graduating from Spartan and all that, I think those things were confidence builders, right? I went from there and I was able to go to consider like an engineering program and consider furthering my education. And so it really just changed everything for me, man. The
That
application.
It's pretty funny going from struggling in high school to having a handful of level 3s. I mean, that's pretty good right there.
It's crazy, man. I have been so blessed. I'm blown away, honestly, myself. And really it just comes down to being able to enjoy it. And like that old saying, if you love what you do, you'll never work a day in your life. And that's definitely my life.
In August, I had the opportunity to talk with ASNT Director Ricky Morgan about his experiences inspecting theme park attractions. Here's Ricky.
I got to work on Jurassic Park after its first year of operation, and we went through and checked all the structural steel, and then we walked the track and inspected about different places on the track, and then at the end of the week we were finished and it turned it back and they repainted everything and it looked like brand new again.
Yeah, that was one of my favorite moments from your presentation at the virtual section meeting, was seeing that picture of you with the big robot T-Rex from the Jurassic Park ride. That's so cool.
Yeah. And that was during the track inspection. I actually got to come back once more and work on the T-Rex that was right before the waterfall. It was just the big head that falls down and shows you. And he had actually overextended past his stops, and so they had re-put him back where he belonged. And so they just had me do some MT in certain areas to make sure that he didn't do any stress to his steel neck.
That's so funny. It's like, when you're talking about something like that, it's, it's an inspection, but it almost sounds like you're like a vet too. Like, oh, I have to go take care of the T-Rex.
Yeah, because you're actually, you're in kind of the head and the neck area from the backside, which it's what's amazing about these parks is that, everything in the front looks great to you and everything, but everything in the back is mechanical and, it just.
Right. It didn't feel like you were actually inside a T-Rex's mouth.
No, it didn't quite feel like it. But you did see the teeth from the inside out, so that was kind of disturbing in a way.
Yeah. No, that thing, the first time I rode that ride, I was somewhat young, but older than I should have been to get as scared as I did when that thing jumps down. They're very convincing.
Yeah. And they move really fast. It's pretty.
Yeah. So you've mentioned VT and MT, so visual testing and magnetic particle inspection. Are there standard methods that end up coming up in this industry a lot, or is it really a variety of things, just depending on what the inspection is?
There really is a variety of things, and it really depends on particular rides. Certain rides like that may have a lot of cabling and stuff, they'll be doing eddy current or magnetic flux leakage on checking cables. If it's structures, it's going to be TMT, PT, and visual. There's other parts that get tested that I'm not familiar with that do some, they do some other electrical testing and that they verify that they're getting the right flows and all that kind of thing that occur. But I would say primarily it's eddy current, visual, UT, MT, PT, RT, visual a lot. But really everything's on the table for them because it's important that they inspect things properly for whatever service it's in. So they may actually have some acoustic emission done occasionally on certain things that may need it. But I would say the vast majority is MT, PT, UT, and visual. Those four are probably the primaries. And then you get RT and the others coming in as well.
Okay. When you're doing an inspection of a ride, is there certain kinds of things that you're looking for that tend to come up a lot as these rides, continue to do what they're doing constantly day and day?
Well, typically, a lot of these rides a lot of them are one-on-one and they're in a park. And what happens is the manufacturing company or the fabrication company get together and they develop an inspection plan. And they, during the service life of the project of the ride or asset, there are certain things they want to check throughout. And sometimes that stuff's identified during their walkthroughs, but they usually have it set up. It's usually something from the manufacturer and from the park, and they give you a list of things you're supposed to go look at. And then a lot of times, since I got to work with them quite a bit, I've been in other parks, and they would get with me and say, go look at other places you've seen other things.
Right.
Just kind of go on your own, go look and see whatever you can find. But they would definitely want me to look at specific things. They'd have an inspection plan whenever you showed up, typically. And what you were planning to what your job was called out. Now there's always once you're on site, a lot of the amusement park rides, someone else in some other part of the park may hear that they have an NDT guy in house, and they'll say, "Can you go over and do this too?" So a lot of times you'll end up several jobs once they find out someone's around. So you could end up in several parts of the park.
Okay. I was going to ask about that because I was curious, if somebody who's listening is interested in pursuing something like this, if it tends to be something that you just sort of build up a resume for as a contractor, or if a lot of these places have in-house inspectors that specialize in these kinds of things, how that career trajectory looks.
Yeah, I would say, the bigger parks, the Disneys, the universals and stuff, they usually have some NDT in-house. It's usually
Mm-hmm.
enough to do the stuff overnight, a lot of the overnight stuff. But usually when they're doing either shutting down a ride or building a new ride, and that's the two different types of inspection too. You have the fabrication and erection portion of putting a ride in, the new work,
Mm-hmm.
and then you have the work continuous and in-service work too. So you have both assets. So the fabrication part, it is really just building your resume and getting that first job in there. It's basically you get in there and they start to recognize you, and you start doing good work, and they call you back.
Mm-hmm.
They get comfortable with you and they call you back over and over. So once you're in there, you're pretty in with most of them, and they do like to see that you've been to other parks actually.
Oh, yeah, that's interesting.
Yeah, in bridge industry, it's similar. A lot of times they'll say you need 5 years of bridge inspection experience to get on a bridge job. But how do you get your first bridge job? So
Right.
a lot of times you have to do it in another state that doesn't require you to have that many years experience to get on. So you get to other places for a while until you get the experience you need to get through the requirements.
Thank you so much to all of our wonderful guests on the podcast, as well as all of you for listening. Again, please share your feedback with us at surveymonkey.com/r/ASNT podcast. You can also connect with ASNT at ASNT Info on Facebook, Instagram, LinkedIn, and YouTube. Thank you for a great 2023, and we hope you'll join us again in 2024.